Hey, what's going on, guys? Let's do this problem right here. This question is asking 2.523 grams of H2 and 200 grams of Br2 are placed in a 450 milliliter reaction vessel. Calculate the equilibrium concentration of HBr in the reaction vessel at 500 Kelvin. They have also provided Kc value. Now let's see how we can do this. First of all, we have to create a balanced equation. The equation that is related to this molecule is going to be this one: H2 gas plus Br2 gas gives us HBr, right? Now we have to balance this equation. We have 2 hydrogen, 2 bromine, so we have to put 2 right here. This is also gas. Now let's see how we can find out. Now the question is asking for the equilibrium concentration of HBr, but in order to do this one we need to know the initial concentration, right? Then only we can create the ICE table. Now let's see how we can find the initial concentrations. To find initial concentration we can use these formulas, that 2.523 grams multiplied by, so we need mole per liter, right? That's our aim, because concentration unit is mole per liter. Now if you think about this, we have molar mass of H2. We can find the molar mass of H2, and if we multiply this one by molar mass of H2, that doesn't work. We have to divide, right? In order to get mole on top, we have to divide. Now let's go ahead and do that. Here we are going to have H2, 2.523 grams of H2 multiplied by molar mass of hydrogen is going to be 1.01, but since we have 2 hydrogen right here, it's going to be 2.02, right? So this is the, if you want the exact value, that's going to be 2.016, because 1.008 is 1 hydrogen. So 2.016 gram per mole, and we are going to have 1 mole on top. So we had to put the conversion factor in such a way that will give us mole on top. That's why we put mole on top and gram in the bottom, because gram cancels. Finally we will end up with mole, but we want moles per liter, right? And here they have given 450 milliliter, right? So 450 milliliter mean that's going to be equivalent to 0.45 liter, because we are dividing by 1000 to convert this one into liter. So we have to put 1 over 0.45 liter, and that's going to give us the concentration, initial concentration. And if you calculate this one, you should get 2.781 molar. Now we have to do the same thing for Br2. Br2 is 200 gram, so this is going to be 200 grams of Br2 times molar mass of Br2 is 159.8, so 159.8 grams per mole. So 1 mole is going to be on top, and then we have same volume, so that's going to be 1 over 0.45 liter. And if you calculate this one, you should get 2.781 again. Now we have the initial concentration. Now we can go ahead and create our ICE table. Let's create our ICE table. So let's write this equation again. We have H2 gas plus Br2 gas gives us 2 HBr gas, right? Now we calculated the initial concentration, so this is also molar. So we are going to have ICE table. ICE, I is initial concentration and C is change and E is equilibrium concentration. Now initial we calculated, that is 2.781, and this also 2.781, and this is not provided right here, this is 0. Now since this is 0, the reaction is going to shift toward right side, so we are going to have plus x right here. Since we have 2 in front of this HBr, we have to multiply by that x by 2, so we are going to have 2x. Here we are going to have negative values in the reactant sides, negative x, and equilibrium concentration is going to be addition of initial and change. Initial 0 plus 2x, that's going to give us 2x, and this is going to be 2.781 minus x, and this is also going to be 2.781 minus x. Now let's create our Kc equation. Kc is product over reactants, product is HBr, so HBr is going to be on top, and whatever the coefficient we have in front of it, that's going to be the power. Here we have 2 in front of this one, so we have to put square right here. And for the H2 and Br2, we don't have any coefficient, so we can just leave it as it is. It's actually 1, so we don't have to put it. So this is going to be H2 concentration and Br2 concentration. Now we have the equation for Kc. Now if we want to write this one in terms of x, we can write this equilibrium values, right? This is actually for equilibrium values. Now if you create the equation, this is going to be Kc is equivalent to HBr, we know that 2x, so this is going to be 2x square over 2.781 minus x, because H2 is 2.781 minus x, 2.781 minus x times 2.781 minus x. Now we have the equation. Now let's simplify this one. I get rid of this part, we need space, right? So let's get rid of this part right here. So let's solve this one right here. We have Kc equation right here. Also we can express this equation as Kc is equivalent to 2x square. Since we have both of them same, we can write it as 2.781 minus x whole square, right? So this is also same as that one. Now instead of putting Kc right here, I can put the value of Kc that is given right here, 400, and let's take square root both sides. So this is going to be 20 if you take the square root, and this is going to be 2x over 2.781 minus x. Now we have to do the multiplication on the side. If you multiply 2.781 with 20, that's going to give you 55.62 minus 20x is equivalent to 2x. Now if we bring this 20x to this side, that's going to be 22x, that's equivalent to 55.62. Therefore x is going to be equivalent to 55.62 divided by 22, and that's where that value is 2.528, right? 2.528. So this is our x value. Here the question is asking for equilibrium concentration of HBr. From the ICE table, we know that equilibrium concentration for HBr is 2x. So we have to find what is the 2x value is. Now let's write that one down. Okay, we have 2x, so let's say HBr. HBr concentration is equivalent to 2x, and we calculated the x value, that is 2.528. So we have to multiply this value by 2. So 2 times 2.528, and if you calculate this one, you should get 5.06 molar, and that's going to be the equilibrium concentration for HBr, right? So that's our final answer. I hope you guys find this video helpful. See you next time.